Hi, everybody. This question, complete the following statement. What? The moment of force about a point is what? Multiplied by perpendicular, forget, perpendicular distance. Okay? From the force to the pivot. Okay. On figure 3.1, draw an arrow to show the weight of the bar acting at its center of mass. Since form, right? Uniform bar, because it's uniform, the center of mass will lie where? Exactly at the center. Where is the center? This is the midpoint of the plank. This is the center of mass. And weight always acts where? At the center of mass. State the distance d from the center of mass. Okay. This is the midpoint. Right? Distance is 0.7, right? And from here to here is 0.7, because the center of mass lies exactly where? At the middle. So this is 0.7, this is 0.7. Distance between the center of mass to what? The center of mass from the pivot. Okay. To find it, we need this distance. It will be 0.7 minus 0.20. Okay. 0.7 minus 0.20. 0.7 minus 0.20 equals 0.15 meters. Okay. Total clockwise moments. Now, as what we mentioned before, we have to determine all the forces that act where? The plank. We have slab here. This is the force of slab X, which is unknown. Force from the pivot, let's say it's Y. Weight and 40 newtons. Okay. The moment of Y, as what we mentioned before, Y is 0 because its line of action passes through the pivot. So we will have moment from 40, moment from weight, moment from what? Concrete slab. Determine the clockwise, total clockwise moment, okay, by using this. Move your finger with the same direction of the force above the pivot, this way. This is what? Similarly, this is what? Move your finger in the same direction of the force about the pivot. Move your finger in the same direction of the force about what? The pivot. So these two forces are forming clockwise moments. Now, the moment of W plus moment of what? Of 40 equals. The moment of W times, W is weight is 30, right? The weight is 30. The distance from the 0.5. Okay, this is the distance. 40. The distance now the distance from 40 to the pivot, from here to here, from here to here, 0 point what? 40. What about this distance? Sorry, from here to here 1.4. From here to here would be 1.2. Okay. This distance 1.4. Subtract 0.20 from the force to the pivot is 1.2. Point what? 2. This is what the total clockwise moments, and we have two forces that act that have a clockwise moment. Force which the slab S exerts on the end of the bar. Okay. Now you know that clockwise equals moment of force what? Anti-clockwise. The slab, as what we mentioned before, make what? Clockwise moment. Move your finger with the same direction of the force about the pivot, so it will form what? Anti-clockwise. Clockwise moment (63 Newton meter) equals anti-clockwise moment, force F or X, whatever, times 0.20 from X watt to the pivot. 0.20. So this force X equals what? 315 newtons. Suggest a change to arrangement figure 3.1 that would reduce the force required to lift the slab. Okay. Exactly like the examples of levers, okay? Example of levers, right? We observe that if we increase the distance from the force to the pivot, if we increase the distance from the force to the pivot, needed force to perform this moment. Okay? We have to increase the distance between 40 and the pivot by moving the stone where to the left. Okay, so this will increase the distance between the force and the pivot, and as will reduce the needed force to perform this moment by shifting Thank you.